Alright guys, in this video we'll be looking at parent functions. Throughout the year we'll be looking at several different functions. So today what we're going to do is we're going to quickly introduce you into some of those parent functions that we'll be looking at throughout the year. So the first one we see here, which we should all be familiar with by now, is the linear parent function. And the equation for that linear parent function is y equals x. And of course this is the graph of our linear parent function. Just as the name implies, it looks like a line, which is why they call it linear. Notice the equation is written as y equals x. If you look at some of the ordered pairs on this line, such as this one right here, that is the ordered pair 1, 1, which says that the x and the y value are the same, just like the equation says. The x and y are equal. If you look at this ordered pair over here, notice how that ordered pair is 3, 3. Again, the x and the y value are exactly the same. So regardless of what point I choose on this line, the points or the x and y values are always the same, which is exactly what the equation says. Y and x are exactly the same. The next parent function we're going to look at is called the quadratic. Now again, some of us may be familiar with the quadratic. Its equation is y equals x squared, and the graph of a quadratic is this U shape right here. Again, this is the parent function. Now, if you look at some of the ordered pairs on this graph, such as this one over here, this is the ordered pair 2, 4. You'll notice that what we've done is to get this y value here, we've taken the x and squared it. 2 squared gives us a 4. Same thing on this side over here. Notice how this ordered pair is negative 2, positive 4. Which again, if you look, in order to get this y value here, we've taken the negative 2 and squared that number. Negative 2 squared gives us a positive 4. So again, this U shape is called the parabola, and its parent function is y equals x squared. The next parent function we have is the square root. The equation for the square root parent function is y equals square root of x. And it starts at 0. Notice how it curves over here in the first quadrant. Once again, if you look at some of the ordered pairs here, such as this right here, this is the ordered pair 1, 1. In order to get the y value, what we've done is taken the x and take the square root of that. Square root of 1 is 1. If you look at this ordered pair right here, this ordered pair is 4, 2. In order to get this y value 2, what we've done is we've taken the square root of 4. The square root of 4 gives us a 2. If you take a look at this ordered pair over here, that ordered pair is 9, 3. In order to get this y value 3, what we've done is we've taken the square root of 9, and the square root of 9 is 3. So again, this is the graph of our square root parent function, and that equation is y equals square root of x. The next parent function we have is called the rational parent function, and the rational parent function's equation is y equals 1 over x. Now notice this graph has two parts to it, or what we call branches. The first part is in the first quadrant, and the second part is in this third quadrant here. So the rational has two parts, or two branches, one in the first and one in the third quadrant. The next parent function we have is called the exponential. Now when it comes to exponentials, there's two different graphs that we could come across. You'll notice the first graph we have here, it increases or it goes up. The second graph you see over here goes down or decreases. Now the equation for both of these graphs or exponentials are y equals b to the x power. Now depending on what b is will determine whether the graph increases or decreases. And if you look below the graphs, the only time we're going to get an increase or exponential, what we call growth, is when that b value is greater than 1, such as a 2, 3, 4, 5, or 6. So if that b value is greater than 1, we're going to have what we call an exponential growth, or it increases. Now the other one decreases or goes down, and the only time that's going to happen is when our b value is a number between 0 and 1, such as a 1/2, a 1/4, 1/8. Anything that falls between 0 and 1 would give us what we call an exponential decay, goes down. Alright, so again, this is called the exponential parent functions. We got exponential growth, and that's this one over here. And we got exponential decay, and that's this one over here. The next parent function we have is called the logarithmic function. and the equation for that function is y equals log of x. Now notice this graph looks very similar to the square root function. However, this one does start in the fourth quadrant and runs up, going through the ordered pair 1, 0, and curves into that first quadrant there. So this is the graph of our logarithmic function. And again, the equation for that is y equals log of x. The last parent function that we'll look at is called the absolute value function. And notice the shape of this absolute value function is in the shape of a V. And the equation for this function is y equals the absolute value of x, which is why they call it the absolute value function. Now, again, if you look at some of these ordered pairs, such as this ordered pair right here, that is the ordered pair 2, 2. In order to get this y value of 2, what we've done is taken the absolute value of 2, which is 2. If you look over here on this side, this is the ordered pair negative 2, 2. Once again, to get this y value, what we've done is we've taken the absolute value of this. The absolute value of a negative 2 is a positive 2. If you look at this ordered pair here, that's the ordered pair negative 4, 4. In order to get this y value 4, what we had to do was take the absolute value of this negative 4, and the absolute value of a negative 4 is positive 4. So again, this is called the absolute value function, and its equation is y equals the absolute value of x, and its shape is a V shape.